Hello everyone. Today, Drew, Sarah, Dan, and I will be discussing coastal marshes and ways to monitor the interacting effects of multiple disturbances within marshes. Coastal marshes are critically important and complex habitats that perform numerous ecosystem services, benefiting human populations living in coastal areas, as well as supporting diverse wildlife communities dependent on them. A few important ecosystem services provided by coastal marshes include storage and recycling of nutrients, sediment retention and accumulation, stormwater surge protection, detoxification of pollutants, groundwater recharge, habitat for diverse wildlife, and carbon storage. Despite these critical ecosystem services, coastal marshes have suffered a long history of disturbance due to direct human manipulation through ditching or indirectly through the introduction of invasive plants and climate change, which is resulting in sea level rise and intensified and more frequent hurricanes. These disturbances all interplay to negatively affect marsh ecology, resulting in the loss of important ecosystem services, functions, and decreasing resiliency. Ditching removes surface water within marshes and dates back to the early 1800s when early colonists began ditching marshes for salt hay production and cattle grazing. This method also became a popular way to decrease mosquito populations by removing their breeding habitats. Ditching fundamentally alters the hydrology and sedimentation within the marshes, but it also increases tidal flow into the upper marsh, which allows lower marsh plants that are more salt tolerant to invade high marsh areas, thus changing plant composition. Despite tidal water flow into the upper marsh, sediment is unable to move beyond the banks of the ditches, and the natural marsh accretion processes are altered. Ditching can also allow fresh water to drain from nearby uplands directly into and through the marsh, which also affects plant composition. Furthermore, ditching can increase areas of exposed mud, increase woody vegetation, and decrease macroinvertebrate populations. Restoration efforts to reverse these effects include connecting ditches to ephemeral or shallow pools and remeandering channels.
Hi everyone, Dan Small here. I'll be going over our method section that deals with our monitoring plan for the marsh study sites. As you can see, we've proposed a detailed plan to monitor all potential major biotic and abiotic responses to the disturbances introduced to you by Raena. Before I break down our monitoring actions, let me introduce you to our different study sites. Our study sites are located in Delaware within the Delaware Bay watershed. The Delaware Bay is of an international importance for shorebird stock sites. It has extensive coastal marshes throughout the bay in both New Jersey and Delaware. And while our study sites are on a local scale, we hope that this monitoring plan that we propose could be adopted by regional biologists, eventually establishing a coordinated network monitoring marshes up and down the East Coast that will allow us to make comparisons to the disparate disturbances that Raena outlined. Our study sites are located 8.5 kilometers northeast of Milford, Delaware. Within this extensive marsh complex, we've established two study sites. In yellow is our modified marsh that was ditched in 1935, and our reference marsh, outlined in purple, has not been modified through ditching. Care was taken while selecting our reference marsh to make sure it was similar in size, geomorphology, tidal range, landscape position, and adjacent land use to our modified marsh. I've included lat and long here if you wanted to look them up a little bit closer in Google Earth. And as you can see, we've established a grid of monitoring locations throughout the marsh where we will be taking our samples from. To monitor hydrology at the site, we will be installing 4 water level transducer stations within each marsh, which will record temperature and water pressure at 30-minute intervals throughout the length of the study. In addition, we'll be measuring salinity, pH, and water table depths at low tide. We'll also be doing soil pore salinity measurements at 15, 30, and 45 centimeter intervals below the soil surface using a handheld refractometer. To measure micro surface elevational changes throughout the marsh due to sedimentation, we'll be using a rod surface elevation table marker, as demonstrated here on the left. And to look at dissolved oxygen, we'll be using a ROX optical dissolved oxygen sensors placed throughout the marsh. We're looking at these every 6 weeks, and this will help us track changes in dissolved oxygen to evaluate whether vegetation are responding to fluctuating temperatures and day length. To better understand marsh elevation and how shoreline may or may not be changing over time, we'll be creating a digital elevation model, repeating this every 4 months using a real-time cinematic GPS, which is basically a super fancy satellite navigation technique used to increase precision of location data. We'll be doing this at 300 locations within each of the marshes. In addition, we'll be looking at LiDAR data that we can use to map topography and bathymetry characteristics of the marsh and the creek channels within each marsh. And in front of you here are examples of the different LiDAR data between the 2 study sites, clearly indicating which marsh has been modified. We'll be doing extensive vegetation monitoring throughout both study sites, looking at plant species composition and measuring percent cover using a modified Dommemeyer scale. In addition, we'll be taking vegetation clippings to measure primary production in the spring, as well as taking photo points throughout the marsh at each of the gridded locations to track changes seasonally. We'll be taking Neptune samples at 2 different creek sizes within each marsh, looking at species composition and richness. We'll be sampling macroinvertebrates in the spring and the fall using a D-frame sweep net. Samples will be placed in 95% ethanol solution, identified a family with particular focus on mosquito diversity and abundance between the 2 marshes. Bird counts will be established at each grid location. They'll be conducted by trained ornithologists proficient in bird identification by sight and sound. Counts will last 15 minutes and be conducted 5 times per season. Here are a few examples of some of the bird species you might find in Delaware marshes.
We expect that the modified marsh will have a significantly shorter hydro period following flood and surge events and lower groundwater levels in general due to the drainage. The water quality would be poorer, specifically the salinity would be lower, and the dissolved oxygen would be based on the biotic response. So if there was more heterotrophs, we would expect to see less dissolved oxygen, but if there's more autotrophs, the dissolved oxygen might actually be higher. The marsh elevation is expected to increase due to higher accretion rates from the presence of non-native species like Phragmites. As you can see here, the Phragmites produces a lot more biomass than the native Spartina smooth cordgrass. We also expect that the shorelines would recede because the native vegetation would not be able to keep up with the sea level rise rates. We expect to see decreased nectin biodiversity and species richness, as well as biomass. The modified marsh would have a lower index of biotic integrity score. and there would be decreased richness and higher percentages of tolerant macroinvertebrates that are tolerant of freshwater. We also expect there to be lower bird density and diversity. We expect to find significantly higher cover and above ground production of non-native invasive species in the modified marsh due to lower soil salinity and higher rates of freshwater incursion. As you can see here in this picture, the upper bay of the Delaware Bay is invaded by Phragmites, and this mostly has to deal with the fresh water that's coming in from inland. And also, when Phragmites displaces smooth cordgrass, the Phragmites grows less dense, and so water velocity actually increases, and there would be a decrease in habitat complexity as well.
One of our main conclusions was that we know a lot about how individual disturbances impact a site, but we don't know as much about how multiple disturbances will influence coastal marshes. So we don't know if a marsh is hit by two disturbances, we don't know if they're going to create more damage or if they're going to balance each other out. One example of this is with invasive weeds. And if you take a weed like common reed, which is invasive to a lot of marshes and unwanted in them, it can have a lot of negative influences. They can impact the hydrology of a site. It can compete with native plants that we want there. But it can also help with sediment accretion. So having any vegetation in an area will help with this sediment and will help stabilize the sediment and prevent erosion. And this will help counteract the effects of sea level rise. So having more vegetation in an area can help prevent it from becoming flooded as sea levels change. So the interactions between disturbances can be pretty complicated and are really hard to predict. So it's really important that we monitor sites well so we can get a better grasp of what happens when these disturbances do interact. And that leads right into our implications for the future. So, one of our main implications was that it's really important to have standardized monitoring for local regions and combine this with large scale remote sensing. So, the technologies for remote sensing have gotten a lot better, and we can use these to look at a whole region and kind of figure out what parts are healthy and what parts look like they might need help. And once we find those areas that need help, we can use well established standardized monitoring to figure out what needs to be done to keep them healthy. And this will require a lot of good coordination between NGOs, federal and state agencies to help figure out what the best use of our time and resources are. So I hope you guys enjoyed our presentation, and thank you for watching.